Good morning, everybody. I want to talk about QuickSort today. Now, the QuickSort is similar to MergeSort. It is a recursive algorithm. It does split the data into smaller subchunks and then sorts them. The running time is also similar. The best case running time is omega of n times log n. Alright, and the worst case running time, unlike MergeSort, you'll notice, is O of n squared. Okay, so this is the best case here. And then we have the worst case. So let's take an example and see how QuickSort works. So suppose I have the following array list of numbers: 7, 2, 1, 8, 6, 3, 5, and 4. QuickSort picks a number at random from the array. We call this number a pivot. So the first step is to pick a pivot. Okay, once you pick a pivot, and picking a pivot is some random number from the array. Okay, so say I picked the number 6. Okay, there we go. So 6 is going to be my pivot in this case. So the next thing I have to do is I have to look at all of the numbers in the array list and all of the smaller number than 6, so all numbers that are less than 6 are going to go to the left, and all of the numbers that are larger than 6, out of way, that are larger than 6 are going to go to the right. So all numbers all numbers larger, and then we have all numbers smaller. Okay, so let's take a look how this could be done. Actually, before I give you an example, let's see how this would work out. So 7 is bigger than 6, so let's go ahead and say 7 is bigger than 6, so 7 needs to go to the right. So 7 needs to go to the right of 6. So I will put it here. Okay. 6 is still staying in the middle. So 6 is still here. Okay. Right there. All right. So we're done with 7. Now we go with 2. Oh, 2 is good. 2 is okay. So 2 will just, stay right there. There we go. 1 is good. So just 1 will stay right there. Alright, then we have 8. 8 is bigger than 6, so 8 needs to go to the right of the pivot. Alright, so let's go ahead and put 8. Okay, we're done with numbers we're done with these numbers here. So let's go ahead and now deal with these numbers. They're all smaller than 6. So 3 will have to go to the right. 5 will have to go to the left, and 4 will have to go also to the left. So I will put 3, 3, I'm running out of room, so I'll just say 5, and 4. Okay. So now we have all the numbers that are greater than 6 to the right of 6, and all the numbers that are less than 6 to the left of 6. So what has this enabled us? That means 6 is in the right place. So the pivot, after the first partitioning here, this is called the partitioning. After the first partitioning, the pivot is going to be in the right place. Okay, and another thing you will notice is that I've reduced my my working space. What I mean by that is I know that all of the numbers here are going to be smaller than all of the numbers here. So all the numbers on the left side are going to be smaller than all of the numbers on the right side. Okay, that means is I don't have to compare any of these numbers, so any of the numbers on the left, I don't have to compare with any of the numbers on the right. Okay, so that kind of narrowed what I need. We narrowed my comparisons. So now I do the same thing. I take the numbers that are on the left. So I have 4, 5, 2, 1, 3. Okay, I pick a pivot. So let's pick. I don't know. Maybe we'll pick 2. And I do the same thing. So I take all the numbers here. So 4 and 5 are greater than 2. So we'll say move them to the right of 2. So we'll have 5, 4. 2 is in the middle. And then on the left we'll have 3 and 1. Okay. So now 2 here, the pivot is in the right place. Okay. And I'm going to do the same thing here, and I'm going to do the same thing here. Alright, I'm going to pick a pivot at random, so let's say pick 3. Okay, 3 is 1 is less than 3, so we're going to go ahead position 1 and 3. So we'll say 1, 3, and then we have oh, my bad. Hold on, 3 is not less than 2, what I was talking about. Let's back up for a second. 3 needs to go to the 3 is bigger than 2, so we'll have 5, 4, 3 there. I'm sorry about that. Okay, now let's go ahead and do this again. 1 is by itself, so 1 is in the right place. If we have one element, it's already in the right place. 2 is in the right place. 3 is always going to be in the right place. And now I do the same thing. I pick a pivot, and then I position the elements to the left and to the right of the pivot. So I have, we'll end up having 3, 4, 5, right? And now 4 is in the right place. I only have one element to the left, and I only have one element to the right. So there's no need for picking a pivot. So now all of the elements are in the right place. Okay. Now I go ahead and do the same thing for the numbers that are to the right of the pivot. So I'm going to go now here on this. I have 7 and 8. I have to pick a pivot. Note that I don't know that 7 and 8 are already sorted, right? So I still have to pick a pivot, and I still have to go through it. Okay, it doesn't work like insertion sort. So let's say I pick, doesn't matter, I pick 7. Right, so now I have 7 there as my pivot. 8 is already bigger than 7, so we'll stay in place. Okay, so now 7 is in the right place and 8 is in the right place. There's only one number to the right, so I don't have to pick a pivot, so I'm done here. Okay, and now I have everything sorted. I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's the idea behind QuickSort. Okay, you have to pick in a pivot until you're done, because as I said, you don't know that the numbers are sorted. Now the question becomes is, okay, well, Vito, how do you decide on picking a pivot? So we have to say how do we decide on picking a pivot? And the question 2 is, how do we implement this? Okay, so I'll address both of these questions in the next video. Thanks for watching this. Let me know if you have any questions, and I'll see you in the next video.